Hello there, guys. Today I have a new video for you. This you can see right here is the BIOS for the new Asus Tuf Z370-Pro gaming motherboard. In case you are wondering what's the thing with Tuf and gaming on the same product, I don't know either. Because there shouldn't be anything in common for the two brands, for the Ultimate Force and for the gaming brand. Also, I can't say I understand what's Asus strategy with all these affordable gaming motherboards lately, because they had multiple changes until now. So it was at the beginning it was the Pro Gamer, then it became Pro Gaming, and now, as you can see, we have Tuf Gaming. So let's get back to our BIOS. This is how it looks. So this is, as you can see right here, this is the easy mode. I also must say I don't understand what's with this background. So this looks like some cheap Chinese stuff. I think this is something that Gigabyte or ASRock would rather be using. So I can't say I understand this. So this is not professional, and I can definitely say I don't like it. But anyway, let's move on. So, on the upper side of the screen, you can of course adjust the date and time right here. So, it's very simple. Next, you can select your desired language. And there's also the Easy Tuning Wizard. This Easy Tuning Wizard is actually the automatic overclocking, one of the automatic overclocking tools Asus provides with this motherboard. So, and this is how it works. So this is the current system configuration. And next, here you can choose your PC scenario. So let's choose daily computing first, and next, and the main cooling system. Okay, so if you are using the box cooler, let's press next, and this is what you get. So 22% CPU performance improvement, and no improvement for DRAM performance. Back, and let's switch to tower cooler. We are getting 25% CPU performance improvement, and the same 0% for DRAM. And finally the water cooler. Next, so 27% and 0. Okay, and if you're not sure, I don't know why wouldn't you be sure, but let's assume you aren't. And next, we are getting back to 22, which is the performance improvement for the box cooler. And back to PC scenario, and this time let's choose gaming and media editing. Next, box cooler. Next, so 25% CPU performance improvement and 28% DRAM performance improvement. So you should note though that this DRAM performance improvement is not actually accurate, because this is based on the 2133 megahertz frequency. So if you are using faster DRAM with XMP profiles, you won't probably see any performance improvement for DRAM. Okay, back, and tower cooler. Next, so 28. This is actually what I'm using right now, but I must say that unfortunately this is not a stable setting for this configuration. I'm using a Core i5 8600K CPU, and if I run some stress test, yeah, the entire system will shut down by itself after 5 or 10 minutes or something like that. I don't know why it does that, because the temperatures are not that high, but it looks like a self-protecting mechanism. And back, and if you are using water cooler, you are getting 31% and 28%. And of course, if you're not sure, you are getting the basic settings. Also, you can use the easy tuning wizard to set up your ride. So this is where you can choose to set up your ride. But I won't be doing this right now, so cancel. Next, there's an information section right here, as you can see. So this is the motherboard, the BIOS version, the CPU speed, and the memory. Okay, so as I told you before, 2133 megahertz, so 2133. Also the CPU temperature right here, the CPU core voltage, the motherboard temperature, and okay, so DRAM status. These are the used channels, and SATA information. Next, you can choose to enable the XMP profile, because these are 3 GHz rated DDR4 memory modules. And once you enable the XMP profile, the BIOS will ask you if you want to use the all-core enhancement. Actually, this is the sync all cores function, which will apply the same turbo multiplier for all your cores, no matter how many threads you are running. This could be also considered overclocking. So if you want to use the completely stock operation values that Intel recommends, you should select no right here. Okay, so I'm going to select no, but you should know that if you choose yes, the system will be completely stable and a bit faster in multi-threaded applications, but also a bit warmer. It will consume more, it will require more power, and most definitely it will be a bit noisier. Okay, so no. Next we have the Intel Rapid Storage technology and the QFan control. So this is the QFan control. This will allow you to set up the speeds for your installed fans, and for the all-in-one water pump if you are using an all-in-one water cooling solution. If you press optimize all right here, the system will automatically scan all the connected fans, all the fans that are connected to your motherboard, and this way it will determine the minimum RPM and maximum RPM settings. Actually, not the minimum RPM, but the minimum PWM value. If you want to set the QFan functionality manually, you should be doing this fan calibrating thing. Okay, so I don't know why it is taking so much time. It should be faster. Especially that I'm only using 2 fans right now. Okay, so this is not going as planned. I'll just wait a bit more, and if nothing happens, I will reboot the system. Actually, this is not a surprise. Oh, okay, so it's done. It took a bit longer than it does on other motherboards. So as you can see, because I'm not using any Asus fans, there's no change right here. But because I'm using Noctua fans for the CPU, as you can see, the the BIOS, the QFan function detected that the minimum duty cycle is lower than the default 20%, and it's actually 14%, and it changed it accordingly. Okay. Also, once you do this optimize all thing, the profile will be automatically set to manual, and it will probably look something like this. Actually, I think this is according to the fans you are using. So this right here, as you can see, it's using the new minimum duty cycle, the 14%, and this is for temperatures below 20 degrees. Also, we have the next level, which is 20% for temperatures below 25 degrees, and the third one, 100% for temperatures below when the CPU reaches sorry, so let's start again. So 14% for temperatures below 20 degrees, 20% for temperatures for the 25% temperature, and 100% when the CPU reaches 70 degrees. Okay, if we can push this a bit further. Okay, so the maximum available temperature is 75 degrees. You cannot go above that, but you can of course decrease the fan power duty, as you can see. So if you are choosing something like this, you will have a lower RPM below 75 degrees, but once you reach the maximum limit, the CPU fan will suddenly go to 100%. Also, you can move this like this, and maybe you want to, I don't know, let's set it to something like this. Okay, so this is not very accurate, and my mouse isn't either, but it's okay like that. Also 20 degrees, it seems too low to me, so I'm moving this maybe to 45 or 40, like this, and apply. Also, you can set this, I'm using 4-pin fans, but if you are using 3-pin fans, you should go to DC mode, and as you can see, this doesn't look as good as before, so you cannot go below 60%. which is pretty noisy with my current fans. So back to 4-pin mode. Also there are preset profiles. So this is the standard. You cannot set anything right here, but you can see the RPM curve. Next there's silent, turbo, and of course full speed. Also you should know that all these changes are taking place instantaneously, so once you select a profile right here, it will be immediately applied to your fans. Next, chassis fans. So we have again the same selection, 4-pin and 3-pin fans. Also for 3-pin fans you can choose to, if you select manual mode, you can select this fan off checkbox. So if your CPU temperature will go, let's say, to below 45 degrees right here, this fan will completely turn off. This is very useful, I can tell you, because if you are watching a movie or some or doing some light computing with your PC, you won't want to hear your chassis fans. I can tell you that. Unfortunately, there's no fan off mode for 4-pin fans, only for 3-pin. But you have the same adjusting tool as for the CPU fan, and the same preset profiles. And it goes the same for the second chassis fans. As you can see, this motherboard only uses two chassis fan connectors, and also you can adjust do some adjustments for the all-in-one pump, which is not installed. Okay, let's exit. Next, there's the easy system tuning. Okay, and there's the boot priority. And this is basically everything you can do with the with the easy mode. And now I'm switching to advanced mode, so you can press this right here or punch F7 on your keyboard. And this is how it looks. Unfortunately, we have the same stupid background, but fortunately it has no more animation, so I find it much better this way. We have a more advanced header right here, so we still have the date and language, but we also have my favorite section. And the QFan control you saw earlier, and the easy tuning wizard, and a short list with available hotkeys. Okay, so the default selected tab will be the main tab, where you can see the information about your system. You can select your language here as well, and also you can set the security settings, so the administrator password and user password. Okay. Also, there's actually the main tab is the second tab, although it is the default one. The first tab is called My Favorites, and so here you can add your favorite settings. Okay. The next one is called AI Tweaker, and this is actually the most important tab because this is well you will be doing all the settings for your system performance. So as you can see, the XMP profile is already selected because I selected in the easy mode, and this here you can see the applied settings. So DDR4 3000 with this latencies and 1.35 volts. Next, the backlog frequency, which okay, so sorry, for a AI overclock tuner, which is set to XMP right now, you can also go for auto, which is the basic default setting, and for manual, where you can select manually all the settings. Manually select all the settings. Okay. Next, the backlog frequency, which goes from 98 up to 538. The backlog spread spectrum, auto, disabled or enable. I am going to enable it to reduce the electromagnetic interference emissions. I'm not doing any overclocking right now, so it's okay to enable it. Next, the Asus multi-core enhancement, which as you can see below, so there's there's a help section right here at the bottom of the screen. This basically will optimize, or this is what it should do, optimize the turbo core ratio settings, and it is set to auto by default. Next, the SVID behavior. So this is correlated to the quality of the silicon of the CPU you are using in your system. So if your CPU won't scale very well with the applied voltage when you are overclocking it, you should go for this worst case scenario. But for stock frequency, auto is as good as any. Next, the AVX instruction core offset. This is a negative offset. So this, if you are overclocking your CPU and it works with your applied frequencies, but it's not very stable in AVX applications, you can set this offset, so it will apply a lower ratio when running AVX applications. And as you can see, you can set it like this. Next, the CPU core ratio. It is, I don't know why it is set to single cores, because I selected no when I activated the XMP profile. Okay, I don't want to. So I want to use the auto. Sorry. The auto core ratio, but if you go for single cores like this, you can manually select the multiplier for all the 6 cores at once. So like this, from 8 up to 83. And if you choose per core, you can adjust this independently in relation to how many cores you are using. Okay, let's switch back to auto. Also, there's some CPU power enhancement. So there's no description for this, but I guess this is some sort of power management feature Asus implemented for this motherboard. Next, the backlog frequency, DRAM frequency ratio. So this is meant for fine-tuning your DRAM frequency, as well as this DRAM odd ratio mode. So this odd ratio mode would provide you with more available frequency values. So with smaller steps. Next, there's the OC tuner, and there are two settings: OC tuner 1 and OC tuner 2. This is the second automatic overclocking tool this motherboard provides, and this is basically a rebranding for the TPU. So you probably already know TPU from other Asus motherboards. I don't know why they chose to rename it on this Tuf Z370-Pro gaming model, but they just did. As I already told you, I don't understand what's Asus strategy with this affordable gaming motherboards. So I cannot say I understand any of their marketing decisions in this area. Next, there's a CPU 5 GHz overclocking profile. This also isn't stable with this CPU, and the CPU SVID support. If you are overclocking the CPU, this is you should disable this. Otherwise, you don't need to change this setting. The DRAM timing control. So as you can see, this is actually pretty comprehensive. I don't think there is even a single user that will buy this motherboard and will use any of these settings. This is, in my opinion, a waste of time and space for this BIOS, for the BIOS on this motherboard. And it's quite a surprise that they also added this DRAM SPD write function, which is actually some enthusiast option, and I don't see the point of having it on this motherboard. Next, you can adjust the settings for the power phase, so the load line calibration to lower the VDRAP, CPU current capability, CPU VRM switching frequency, so you can set this to manual and get it up to 500 kilohertz. VRM spread spectrum, CPU power duty control, and CPU power phase control. Next, internal CPU power management. So, because I want to use the minimum amount of power possible, I'm going to enable this and leave the rest to auto. F-clock. Okay, CPU core cache current limit. So this goes up to 255.5. The ring down bin is also available. The minimum and maximum CPU cache ratio, this goes from 8 up to 83, and it's the same here. Okay, as you can see, there's also the extreme over voltage option, but in order to be able to use this, you need to switch the jumper on the motherboard. As I told you, this is not an enthusiast motherboard, so I don't think you will want to use this extreme voltage option, because this is not a motherboard designed for extreme overclocking. Okay, so backlog aware adaptive voltage, this should improve your backlog overclocking. CPU core cache voltage, core and cache voltage. So by default the motherboard will have this set to auto. If you are overclocking the CPU, you can choose manual, and this goes from 0.6 volts up to 1.7. Also you can go for offset mode, positive or negative offset, and the CPU core voltage offset. So it goes from 0.005 volts up to 0.635 volts. And finally there's the adaptive mode, which will allow you to set the offset, and it goes from the first setting is the additional turbo mode. It goes from 0.25 up to 1.52, and the offset voltage goes from 0.001 volts up to 0.999 volts, and you will end up with up to 2.519 volts, which is pretty huge. Okay, I'm going to put this back to auto. Next, there's the DRAM voltage, which goes from 1 volt up to 1.8350 volts. I'm going to put this back to 1.35 because this is the standard voltage for my modules. And of course there are other voltages you can adjust right here. And there's another tone of DRAM overclocking options that nobody will be using. Okay, let's move to Advanced tab, CPU configuration. Okay, so this is some info about your CPU. Also, the thermal monitor is by default enabled. You should disable it for overclocking, and you can select how many cores you want to use, and you can also enable or disable the Intel virtualization technology, the hardware prefetcher, adjacent, anyway, cache line prefetch, boot performance mode. So maybe you are using some turbo settings that are not 100% stable, but you still want to boot your system, so you can go for maximum non-turbo performance. Okay, TSGX, and so, and the power management control. So the speed step, okay, sorry, the speed step is already enabled because I enabled it earlier. The turbo mode is enabled by default. The C states, I want to enable this as well. Okay, so everything is enabled here. And the speed shift technology also enabled. Platform is miscellaneous configuration. Okay, so PCI Express native power management, I'm going to enable all of this because, as I told you, I want to lower the power consumption as low as possible. Of course, this could have a negative impact on the stability of your system. So if it doesn't work, you can disable them. I already tested this system, and it's totally stable with these settings. Okay. Next, here we have the VTD, the graphics configuration, and the iGPU multi-monitor. If you want to enable both the integrated and the discrete graphics. Okay, the DMI max link speed, and the PEG port configuration. Next, settings for your PCH, so PCI Express speed again. PCH storage configuration, so SATA controllers enable, SATA mode selection, so HCI or Intel RST with Intel Optane system acceleration if you are using an Intel Optane device. Smart status check. Okay, here you can rename the SATA ports, so you can easier identify your devices. You can enable or disable them, and enable the hot plug functionality. And you can do this for all the available SATA ports. Sorry. Next, PCH. Okay, so here you can set the TPM and BTP aware operating system. The onboard devices configuration, so the audio controller, the Tough gaming LED lighting. So there are only two modes available, static and breathing. You should know that this is not RGB. This is one color illumination. It's orange, I think. And the status of the lighting solution under S3, S4 and S5 modes. Next, the M2 slot, the first M2 slot, which can work as SATA or PCI Express, and Hyper M2 X16 if you are using any, AVerMedia backed USB 3.1 controller, Intel LAN controller, Intel LAN PXE option ROM, serial port config, and escape. APN configuration, ERP ready, of course, I want to use this. Restore AC power loss, no, I don't want my computer to start or use the last state. Maybe I'm not even in front of it. Power on by PCI Express and PCI, by ring, or by RTC. Network stack, HDD or SSD smart information, and USB config. Here you can enable or disable individually each and every USB port provided by your motherboard. Next, there's the monitor tab. Here you can see the monitor temperatures and fan speeds. And of course the used voltages. Also there's the QFan configuration, the same you saw before, only this time is not this is not the graphic mode. This is the more advanced mode, the more manual mode. So you can add a delay for fan step up and fan step down like this. I'm going to add this delay for fan step up because I want my fan to wait until the CPU temperature will stabilize a little bit. Okay, I'm going to ignore the lower limit and let me show you how the manual setting looks like. Okay, so as you can see, you have the upper temperature, the maximum duty cycle, the middle temperature, the middle duty cycle, the lower temperature, and the minimum duty cycle. These are the same that you could see earlier on that chart. I'm going to put this back to silent. And of course there are the same settings for the chassis fans. Of course you can choose the temperature source. It can be the CPU, which is the default selected one, or it can be the motherboard or the PCH. Also there's a delay here as well, and the same manual settings. Because this is an open platform and I'm not using any chassis fans, I'm going to completely disable the QFan functionality for this too. And the all-in-one pump control this time. So as you could see, it was disabled, but you can enable it right here and do your settings. I'm not using any water cooling solution, so I'm going to disable this as well. Next, there's the chassis intrusion detection support, and that's all. Let's move on. This is the boot tab, so the fast boot, next boot after AC power loss, above 4G decoding, boot configuration, so you can choose to see or not the boot logo display. I'm going to disable this because I want to see the power on self-test screen. Okay, the numlock state, and what happens if you have an error, option ROM messages, and I want my BIOS to boot into advanced mode, not easy mode. Next, the compatibility support module, the secure boot, the boot option priorities. Here you can override the boot selection, and that's it. Next, there's the tool tab, Asus Easy Flash 3 utility. So this is used to flash your BIOS. You can search for updates via internet, or you can use a storage device that contains your new BIOS. Okay, so next, this is how it looks. I'm already using the latest BIOS, so there's nothing to do here. And exit. Okay, secure erase. You can use this little tool to restore your SSD performance. So this is probably something like a low-level format or something, and basically it will erase everything on your SSD, and it should restore its factory performance. At least this is what Asus claims. Okay, setup animator, this is disabled. Let me show you what happens when I enable it. Okay, so this is the animator. Let's disable it back. Okay, Asus overclocking profiles. Here you can save and load the profiles. I already saved mine, and you can as well load and save profile from into a USB drive. Asus SPD information and graphics card information. So this is the BIOS for the new Tuf Z370-Pro gaming motherboard. It is pretty complex. It's much more complex than I was expecting. And before I exit, let me show you what I did for overclocking my CPU using this motherboard. So let's load the overclocking profile. Okay, and AI tweaker. Okay, so I'm still using the XMP AI overclock tuner setting. I'm using the default backlog frequency. I disable the spread spectrum. I chose to use the worst case scenario. I'm not using any offset for AVX instruction because I want my CPU to be 100% stable. So this overclocking is for daily use computing. I'm using the same core ratio for all of the cores, and this is 49. Unfortunately, I had to stop to 49 because above this value the system became either unstable or it was shutting itself down. I didn't overclock my DRAM memory. Okay, I disabled the SVID support and I kept the DRAM latency from the XMP profile. Next, the power phase control. I chose to use the level 7 load line calibration, and I'm still having some low V drop, but it's still there, so this shouldn't normally happening. I'm using the maximum CPU current capability, and I didn't change these following settings because the motherboard became unstable. I don't think why this is happening. Perhaps this is a buggy BIOS or something. Internal CPU power management, as you can see, I disabled the speed step as well because it wouldn't run stable with the speed step enabled, and I set this to maximum available settings right here. Also the current limit, I set it to maximum value. I disable the ring down bin, and I set the CPU core and cache voltage to manual mode, and 1.28 volts is the maximum stable voltage I could use, because above this voltage the system would shut itself down randomly, sometimes sooner and sometimes later. But keep in mind, this only happens in stress tests. And the rest is unchanged. And in the advanced tab, the CPU configuration. Okay, so I disable the hardware monitor. I chose to boot using the max non-turbo performance. And for CPU power management control, as you can see, I disabled all the power management features in order to make the system stable. The same here. And here. Also, unfortunately, I had to disable the CPU QFan control. I don't know why, but when setting this to silent mode, the system refused to run stress tests. My guess is that it has something to do with the VRM, so with the power phase. I don't know exactly what is happening, but I can tell you this motherboard is not your best choice for overclocking. Okay, so this is basically everything I wanted to show you. Thank you for watching, and see you next time.